we're live. Awesome. Okay, so this is the second meeting we're having. We're reading You Don't Know JS book series, which I think, Clayton, you were the one who suggested this, right?
I was.
All
There
right.
goes as well.
It's a good book series. I'm enjoying it, and I'm not really sure who it's targeted at. I guess it's targeted at people who maybe know a little bit about programming but don't know a whole lot about JavaScript, which I guess then fits in with the title. But it's not like super advanced, but I think in this section it did go a little bit into like compiler theory stuff, which could be advanced. But I thought they explained it well.
I learned new things.
I did too. So I guess without further ado, let me switch it over and we can start talking about it. Yeah, I definitely learned a lot in this week's chapters. Okay. Let me flip it over to... All right. So You Don't Know JavaScript, Book 2, Scopes and Closures, Chapters 1, 2, and 3. And you'll notice, in case, I don't know if anyone who uses the Oxford comma is here tonight, but I appease both the people who do and don't by putting it in, sort of.
It's a ghost comma.
You'll have to leave comments. If you're an Oxford comma person, leave comments. The ghost comma. All right, so last week we did Up and Going. If you missed that, there's a link there. If you want to participate, I made on the codenewbie.org discourse, I made a thread. If you see this and you want to be able to participate and you don't know, if you don't know JavaScript like us, or if you aren't sure how to get involved, you can post on there and someone can help you. And then I made a short version for people who don't want to have to click and type in that big long thing. So it's just bit.ly codenewbie or cn- you don't know JavaScript. Okay, so today we're starting off book 2, which is Scopes and Closures. There's a link to the book, there's a link to the online version of the book, and the book looks like that. So the first chapter starts out by talking about scope and what is scope. And I think that's a big focus of what all 3 chapters are talking about for this week, is scope and how it works in JavaScript. But what is scope? Well, they started talking about scope by talking about variables. And variables, the way I like to think about variables, and I think a lot of people like to think about them this way, is it's kind of like they're containers that you can put names on and you can put stuff in them. I don't know, is that how you would describe a variable, Clayton, or do you have another definition?
They're names for something.
Yeah, that's a good way of putting it. But once you have a variable, how do you find it? And the answer to that is scope. So once again, what is scope? And now for something completely different. Compiler theory.
Yay.
So to understand scope in JavaScript, you need to understand a little bit about how the compiler is working. And, well, a compiler, first of all, what is a compiler? A compiler is what, essentially, it turns your JavaScript code into an executable thing on whatever platform you're using, and then something awesome happens. And JavaScript uses a just-in-time compiler. I wasn't aware of this. I thought it was an interpreted language, but I guess a lot of interpreted languages are now kind of switching over to this.
I think that most languages you don't compile in advance, or do you know what languages would be interpreter languages?
So, like, interpreted would be what, like JavaScript, Ruby, Python. I think the ones that are typically considered like scripting languages, right? Like Perl.
Yeah. So I
But
think so. Ruby. So Matz's Ruby interpreter is the name for core Ruby MRI,
mhm.
and so I think Ruby is like at least like standard MRI Ruby is um, interpreted, but I
Mhm.
know that there are versions of Ruby that have compilers. JRuby and Rubinius are both compiled
Okay,
using the JVM.
that makes sense. Well, yeah, if it's on the JVM, it would make sense that it's compiled. Um, Python, I'm not exactly sure how it works under the covers. I've noticed that the Python.py files will sometimes leave these artifacts around that are PYCs, so that's compiled Python.
Hmm.
So there's something going on there. I'm just not exactly sure what it is, but there's some kind of compilation. I don't know if it actually uses a full compile cycle, but it does do something
Oh,
that leaves artifacts.
so I just found a comment on a blog post about Ruby that says MRI Ruby since 1.9 onwards has its own VM,
Hmm.
the YARV, yet another virtual machine, I guess. I don't know.
Okay.
And so MRI also compiles and then executes.
Okay. So then JavaScript is much like these other languages that are taking advantage of this compilation rather than just straight interpreting.
Mhm.
And that's why we're studying a little compiler theory. Okay, so how a computer works, and basically what they explained was, or sorry, not computer, compiler, how a compiler works.
How a
Uh,
small but important portion of the computer works.
they look so similar, and yet they are quite different. um, so there's three basic steps that are going on. They said that that's a bit of an oversimplification, that there's actually other stuff going on, but there's three main steps that happens in a compiler. And the first step is tokenizing, also known as lexing, and that is where the JavaScript code is broken down into little pieces. And from what I could tell, those pieces were typically like each word or operator. So, like if you had a equals x semicolon or a equals 2 semicolon, then it would break it down, and a would be one token, and equals would be another token, and 2
Right,
would be a token, and then semicolon would be a token, right?
right.
Okay, and then it sprinkles a bit of chemical X on each one of those tokens for enhanced flavor. Oh wait, no,
Okay.
because there's a note at the bottom that says that items in orange aren't true, and they're probably false. So that's not true.
It's policy.
It's falsy, yes, falsy for sure. Okay, so that's part one is breaking up the code into little bits, and then parsing takes place next, and that is where the compiler will arrange those tokens into what's known as into a tree hierarchy, and it's known as the abstract syntax tree. I don't
Huh?
know a whole lot about this, but I assume that it has to do with it's ordering that, right? It's saying, okay, I need to do this, and then I need to do this, and then this happens
I mean,
next.
my best guess, best guess is a search tree and it walks the tree.
Okay,
What if you ever do have you ever built a search tree,
I have
like a
not.
binary search tree or something like that?
No.
Yeah. I mean, I'm guessing that's the closest thing to a to a tree in coding I've done is a binary search tree where like it's a way of structuring a bunch of stuff in useful and easy to access ordered ways. But it might not be it at all. I don't know. This is all completely new. Never had a college class on any of this, so yeah,
Yeah,
just
yeah. If
giving
someone
what little bit of context I have to it, which is probably not at all accurate context.
Well, it's more accurate than what I know about it, which is just that it kind of puts it into a tree.
Okay.
And it's not true that bugs lay eggs just under the bark of the abstract syntax tree. Although sometimes you might feel like that does happen. At least I do.
Yeah. No, the bugs are part of the tree.
They are part of the tree. Okay. And then the third step in compiling is that the code generates. So your JavaScript code that has been tokenized and parsed is then turned into binary instructions that your computer can run. So those are the 3 steps of the compiler. And then the book went on to talk about the JavaScript engine and friends, which I didn't put it on here, but that really made me think of Thomas and Friends.
Oh, I was thinking Spider-Man. It's amazing.
Oh, Spider-Man and Friends would work too. Yeah. Okay, so the JavaScript compiler has an engine and some friends. The engine itself is what's in charge of compiling and executing a program, and its friends are the compiler, which compiles and generates the code, and the scope, which collects and maintains a list of valid stuff, valid names, valid variables. And yeah, like function names, variables, and things that aren't keywords in JavaScript.
Right. Scope is like the secretary.
Kind of, yeah. It's like, I'll hold that for you. And it's very organized too, right? Because it puts it in the right place. It's like a filing cabinet or a nested filing cabinet. That probably doesn't work. Okay, so then it asks you to think like an engine. And first, the compiler is processing your code, and it finds a variable. It looks for the variable, and if it finds it, then it just moves on. It's like, okay, I already know that this thing exists. But if it doesn't find it, then it's going to add that variable to the scope friend that it has. And the scope friend will take it and say, oh, I've got this variable now.
Okay.
All right, and then in part 2, JavaScript engine is going to execute the code. So it comes across var a equals 2. It looks for that a in scope, and if it finds it, it says, oh, yeah, that's going to now equal 2. Otherwise, it's going to say, oh, I don't know what this a thing is, so I don't know what to do. I give up.
Right.
So then we got into an area that was really interesting to me. It's something that I had, granted, I really didn't know any of this stuff so far already, like the compiler theory stuff, but this was like, I found it interesting because I didn't even know that this was a thing.
No,
but,
maybe it
but there's a
like. It always makes sense when you start, like, yeah. Go ahead.
Yeah, it totally makes sense. You're right. So the left-hand side lookup versus a right-hand side lookup. So left-hand side lookup basically says find or create this variable and assign a value to it, right? So like here we'll look at this. Oops, what did I do?
So the a and the a equals 2.
Exactly. It says, okay, either find a or just make an a and then make it 2.
Right.
And then this one here is the right-hand side lookup, where it says go find and possibly execute this and give me the result. So in this case, that would be the a here, where it's not saying if you don't know what it is, then make one. It's saying I want to know what this is.
Yeah, go find it.
Yeah, exactly.
Do whatever is associated with it, and then spit it back into the stuff on the left.
Mm-hmm.
So you could do both at once. Like, I guess, like, so if you did like a equals and then some logic that you execute immediately, then
yeah, I mean, you could definitely have both in one statement. You could have a left-hand and a right-hand side lookup, for sure. So here is a little more on left-hand versus right-hand side, and how it works with this function here. So the left-hand side lookup, this one is actually, I probably should have put it second because it's a little more complicated as to what's going on here. But there's a left-hand side lookup in this function right here at runtime. So we're passing foo to this function, and it is getting a left-hand lookup when it goes into here,
Right.
where the compiler is going to say, "Hey, do you have an A inside this function?" or to the scope, and the scope will say, "No, but I'll make one," and then it assigns 2 to A.
Right.
So that's a left-hand side lookup. And then we saw the console log A. That's a right-hand side lookup. But also this foo right here is a right-hand side.
Right.
So there's this section I thought was kind of funny. I don't know if we want to read through it all, but
sure.
All right, let's do it. So like the engine starts out and it says, "Hey scope, I have a right-hand side reference for foo. Have you ever heard of it?" And that would be on this line right here.
Yeah.
And the scope says, "Why, yes, I have. Compiler just declared it a second ago. He's a function. Here you go." So the declaration for foo is right here. Scope recognizes that it had just defined foo, and it gives that, I assume, the function back to the compiler, or the engine, sorry.
Well, yeah, the scope gives it to the engine. The compiler was the one that declared it.
Right, yes, exactly.
When you compiled the function.
Yep. So the engine says, "Great, thanks. Okay, I'm executing foo." So now we're up here, and it says, "Hey scope, I've got a left-hand side reference for A. Have you ever heard of it?" That would be, I assume it's this one here.
Yes. Well, when you call foo, it says, "Hey, whatever your argument that gets passed with it, that gets assigned to A. So A is the left-hand side lookup."
Yes, exactly. So the scope says, "Yes, I have. Compiler just declared it as a formal parameter to foo just recently. Here you go." And the engine is very, very polite. It says, "Helpful as always, scope. Thanks again." Now time to assign 2 to A. So it puts that 2 into A. And then it says, "Hey scope, sorry to bother you again. I need a right-hand side lookup for console. Ever heard of it?" And I didn't mark that. I probably should have marked that. So console here. "No problem, engine. This is what I do all day. Yes, I've got console. He's built in. Here you go." So it gets a reference to console. Engine says, "Perfect. Looking up log. Okay, great. It's a function." And then, "Yo, scope, can you help me out with a right-hand side reference to A? I think I remember it, but I just want to double check." And that would be this A here. And scope says, "You're right, engine. Same guy, hasn't changed. Here you go." And engine says, "Cool. Passing the value of A, which is 2, into log." And then it goes ahead, and now that it has all the references it needs, it goes ahead and executes that, and it's done. So I thought that was a really interesting interaction, but showing how scope works. I never really thought of scope as a thing, like an actor in the software. I always thought of it as more kind of concept.
More like a state of being.
Yeah, exactly.
In or out,
Yeah, totally. But in this view, it's more of an actor. It actually does something. It keeps track of your stuff, and it's there, and yeah, I thought it was neat. Okay, so I've got a scope quiz for you. Looking at this code here, there are 3 left-hand side lookups and 4 right-hand side lookups.
Okay.
Let's see if we can find them all.
So I'm going to say, well, let's do the obvious one. Bar C is the left hand.
Yep.
And then the A on function foo is the left hand.
Yep.
And then var B is the left hand.
Yep.
Okay.
That's all the left hands. So 4 right
Now
hands.
let's see, we have foo when it's called.
This one here, yeah.
We have A when it's called on var B.
Okay, right there.
And we have A plus B.
So that's 2 right there, right?
Yeah, I think so.
Okay. Yeah, I think that's it. I think that's all of them. Yay, we passed the scope quiz.
Yay.
All right, so here you can see that I was reading this on my phone because the screenshot is a different direction. And so basically, scope is nested. It can cascade up, and each one of these, they call them bubbles. The rainbow bubbles, they're in different colors here, is a different level of scope. So this scope here that's in blue is the scope of this function bar. This yellow scope is the function of foo, and then this green area, I assume, is global scope.
Well, it's top level main scope.
Or top level, yeah.
I think it's global scope is how they call it in this book, though.
Okay.
You're right.
Cool. And then it went on to talk a little bit about errors, and I think this is probably useful when you're coding in JavaScript, which I wasn't doing. I was just doing the academic reading. But
it lets you know when you get an error, it lets you kind of know where you failed.
Exactly. Whether or not it's because there was a scope issue or it was something else. So if a right-hand side lookup fails to find a variable in current or parent scopes, a reference error is thrown, and that reference error tells you that that scope failed, basically, right? Your lookup failed because there wasn't anything in scope that was called that. When a left-hand side lookup fails, it will make a new variable in the current scope for you. So it's not going to throw that reference error. It's just going to say, oh, well, I don't know what this is. You were doing a left-hand side lookup, so I'll just go ahead and make that for you. And then it goes on to say that a reference error is an issue with scope resolution, whereas a type error, if you get a type error back in JavaScript, that scope resolved, and then you try to do something with the value that was there, and that action that you were trying to take was impossible. Like if you were trying to divide by 0, might give you a type error. Yeah,
or if you tried to call some function on something that was limited in number, but it was not a number.
Yeah, totally. Like if you tried to, I don't know, divide a turtle.
Yeah, sure.
Divide a turtle. All right, so chapter 2, lexical scope. This chapter was pretty short.
So I actually have experience with lexical scope before this chapter.
Okay.
I have given a talk on Ruby's refinements before. And
Nice.
Ruby's refinements are all about lexical scope. So after you read this chapter on lexical scope, you'll actually understand Ruby's refinements a lot better.
Right on.
Yeah.
That's cool. Okay, so lexical scope. So lexing, what is lexing? It's tokenizing, and that was the first step that we saw in our compiler, where it takes the code and it chops it up into little bits of stuff.
Yeah, it's chunking.
Chunking. That's a word I haven't heard before. That's the same thing?
That's what I call it.
Okay, I like it. It sounds sounds cooler than lexing. Or tokenizing, chunking. I like it.
Well, I actually think lexing is a linguistics term.
Oh, really? So
Ever heard of like lexical linguistics? So I think that comes out of linguistics.
Nice. Okay, so lexical scope is defined at lexing time, and lexing time is the time when the code is chopped up into tokens. Or that first step in the compiling. There was a reminder that scope is nested. And so kind of, I guess I kind of skipped ahead to shadowing here.
Uh-oh.
But basically the thought there is that lexical scope is it's the primary way of scoping in JavaScript. It's what we've talked about so far as scoping goes with the different actors there in that conversation, and that's all happening when the code is being tokenized. It comes across a token. It says, "Oh, here's a scope. Do you know what this is?" And if it's a left-hand or right-hand side lookup, it does like we talked about.
Yeah, and it's like Russian dolls. Like, if you define it on the outer layer, it contains all of the scope inside of it. But if you define it on one of the inner layers, it doesn't contain the stuff outside of it. Like, it won't.
Mm-hmm.
You don't have access to it above. You do have access to it below.
Which turns out to be really handy when you want to avoid things like declaring things at a global scope level.
Right. And also, so like the shadowing thing, you can do this in any language, I think. Mm-hmm. Shadowing, mm-hmm. where like you define a method or define a variable, and that variable still exists in scope, and you define it at a different level but still in scope, and it overrides the mm-hmm. outer variable.
Yeah, it totally.
Generally bad practice.
You know, I find that I do it. Yeah, I do it. But I do it when I'm like referencing the same thing.
Yeah.
I probably
for not paying attention and forgetting to, like, you're using the same like name of like it's sometimes it's easy to do.
Yeah, and totally.
A good editor will let you know you've done it.
Yeah. Yeah, that's true. But when you don't do it, sometimes like you end up like having to come up with a different name for the same thing, and I don't know if that's better. So like if you have a function that, I don't know, you have a program, and that program, like what does it do? It flashes lights, right? And you have a function in there called flash green light and flash red light, and then you have your main function that just says, here's a light, make it flash green, make it flash red.
Yeah.
So your variable on the outside is light, referencing that light object, and then you pass it into that function, and you could call it in that function, you could call it light again, but then that would be technically shadowing, right? Because it's defined at the outer scope, and now you're defining it in that inner scope as light. So then you have to come up with a different name for that, which is maybe it's green light, or I don't know, but I guess the what I'm trying to say is it's difficult to name things.
Yes. It's very difficult to name things. Yeah. One area where I've accidentally, especially when I was first getting started, would run into it was with blocks and Ruby. Mm-hmm. Because, like, let's say I defined some variable outside of a block, and then I started a block, and when you define a block in Ruby, you define variables for the purposes of that block. Mm-hmm. And if you're new to coding, sometimes you will define over variables that exist outside of the block with the same name and get unexpected behavior as a result. Because you don't,
Because your scoping is, I could see that.
Yeah, and also like an example where lexical scope, like this kind of nested scoping occurs, is like, let's say I have some array, and then I run some block, and each item in that block I pass into that array. Well, that array didn't get passed into the block; it just exists at a higher level, but it's still in the same scope. Mm-hmm. For the purposes of lexical scope. It's not in the same scope for the purposes of the block scope.
Okay. Huh. Yeah, Ruby gets interesting with that.
Yep. Ruby's lexical scope is weird though, and I don't have any, like, I don't understand the edges of it because it's not. JavaScript's lexical scope is actually fairly intuitive.
Yeah, it is. It's for the most part, it's functions. Functions have their own scope.
Yeah.
There's a couple nuances, but that's most of it, right?
Basically.
Okay. So if you do happen to shadow a global variable, you can get to it still, because the global reference
Is window.
is window, yeah, in your browser,
Yeah.
or maybe if you're in like V8, it's whatever it is for V8. But
Right.
there'll be a top level object that you can reference that
Yeah.
as a view of, which is handy.
Yes. Though it's still bad practice. You can avoid it.
All right, fair enough. I'll give you that. This one, scope and functions. I didn't quite get this. I don't really necessarily know what foo bar baz means, but basically what it's saying here is that lexical scope is only going to apply to this first item, and then the remainder of these are going to be going to follow object property rules. So bar here will need to be referenced on whatever foo happens to be, and then baz would need to be referenced on whatever bar happens to be.
Yeah.
So
Isn't this a case where so foo, bar, baz, bar and baz are not defined inside of foo, correct? This is just bar, foo, and baz are all. So okay, so how do so it's dot methoding. So like whatever foo returns, then you're calling dot bar on that, and whatever bar returns, you're calling dot baz on that.
exactly.
Yeah, so they're not nested inside of one another. Yeah.
I'm not sure I understand.
Oh, so you can define functions inside of functions. These are not defined functions defined inside of functions. These are functions or called on functions. So bar is not defined inside of foo, and baz isn't defined inside of bar, right? You're
right.
calling like foo, and then whatever foo returns, you're calling bar on that, and whatever bar returns.
We're chaining.
I think, yeah, I think.
Oh, I don't know. It didn't make a whole lot of sense to me. So I'll say yes because I'm not sure.
I think that's right. Hang on. Let's look at the book. What part of the book was that on?
That was
chapter 2 now, right?
Yeah.
Let's see if we got foo.bar. Here we go. Lexical scope lookup process only applies to the first class identifiers such as the A, B, and C. If you had a reference to foo.bar.baz in a piece of code, the lexical scope lookup would apply to the finding the foo identifier, but once it locates that variable, object property access rules take over to resolve the bar and baz properties respectively. So hang on, let me look up what A, B, and C are up here.
Where is it? It's in here somewhere.
Oh, because bar is defined inside of foo, yeah. And then it doesn't have baz in here. Let's see.
Oh, I see.
I think. I'm not sure.
Yeah, I think you're right. I think you're right. I think it is because it's object property. So it's just saying that bar is part of the object foo, and then baz is part of the object bar.
Yeah.
Yeah.
Yeah. Which makes sense.
Yeah, that does. Okay. There we go. Okay, so cheating lexical scope. We said that lexical scope is the primary scope in JavaScript, and that's the case. You can cheat it. There are eval and keyword or eval and width keywords that will allow you to create a new scope. And it says basically, yeah, it's going to create that scope at runtime, but that kills a lot of the performance enhancements that are built into the JavaScript. So don't do it. So I'm just gonna ignore eval and width, I think, for now. And
my experience in languages is that anytime you see the word eval, you should probably be trying to avoid it in any language.
Yeah, when I first found it, I thought this is really awesome, and then I started learning about the holes that it opens up in your software, and Yeah, not
I
so.
don't know. Is there an eval in Python
Yeah, I'm
or
pretty sure
something?
there is. Yeah, I'm pretty
Yeah,
sure
I know
there is.
Ruby has eval methods, and therefore therefore they're dangerous, and you shouldn't use them if you can avoid them.
Yeah, yeah, exactly. Because anything can get in there.
Right.
All right, and that's the chapter.
Yeah. Block
Yay!
scope. Block scope. I get.
Block scope. All right, so function scope first. So the most common type of scope in JavaScript is function scope. Each function creates a new bubble of scope around it. This is called function-based scope. And hiding your code inside a function scope, a function scope bubble, is good practice.
Yes.
And in fact, most of this chapter is going to talk about hiding your code inside of scope bubbles.
My experience, the more you put your JavaScript inside of functions, the happier you're going to be.
Yes. Yeah, it definitely seems that way. When you hide your code in there, it prevents both intentional and unintentional variable collision. You're not polluting
Yep.
the global namespace, and
Yep.
things are just cleaner. There are a couple other ways that you can do to hide your code. The first one is global namespaces, which is shows an example of over here. And I think this is a lot like what jQuery does, right? Because you start your jQuery off with that.
Oh, buddy, you're preaching to a guy who has very little experience with jQuery.
Okay, I don't have a whole lot of experience with jQuery, but I know that like pretty much all jQuery starts with that $sign or whatever.
Yeah.
And I think, and I could be totally wrong, but I think that's an example of your global namespacing where you just have that one token that says, okay, now I'm talking about jQuery, and then it goes on from there.
I see.
There's also apparently modules in JavaScript, which they said they would talk about later.
Yes, we get to later.
So problems with using functions for scoping. You're still polluting your global namespace if you have a bunch of top-level functions. You're still, each one of those functions is going to reside in that global namespace. It might not be a variable. It's going to be a function, but
So
it's
my
still
experience, you
there.
define one top level function.
Okay.
And you put all your other functions inside of that.
Okay.
Like that's my, like that's how but I mean that may not be best practices, but that's the approach that I've taken.
Okay, that makes sense, and that seems like it's almost more like this here, the global namespace idea.
Kind of, yeah.
Okay, so it says the other problem with using functions for scoping is that when you're wrapping your code inside of a function, you then, after you've defined it, you then have to take that extra step of executing it because the function doesn't execute itself. Unless you have a self-calling function, which we talked about last week.
Those are ifs.
Ifs, yes. This is going to evolve into ifs here in a minute. So by adding the parenthesis, open paren before your function, sticking a paren after your function, and then putting the little calling parens after that.
Yep.
You create a self-calling function. It's going to declare itself, and once it's finished declaring, it's going to execute itself. And because it's a function, it's going to wrap that scope. So this A is going to be scoped inside of that function rather than outside of the function.
Yep.
It doesn't live in the global namespace, so that function
it is nameless.
Is nameless, even though it has a name. And it executes immediately.
Yes. I don't think you can call foo, though.
Right, exactly.
I may be wrong, but I don't think foo is callable after that.
Well, I think you can, but it's scoped where you can call it.
Yes, I don't think you can call it on the top level, though, can you? Can you call foo like right there after console.log?
No, I don't think you can. Okay, so then it sidetracks a little bit and then comes back. It's going to talk about what we were just talking about, anonymous versus named functions, or what we were kind of getting into there. So anonymous functions are handy, and these are going to be, so like in Ruby, these would be like lambdas, right? Or maybe procs.
Yes.
One
also,
or the other, both.
Technically blocks.
Yeah. Okay.
Like that's basically what a block is an anonymous function that gets called immediately. Okay. Lambdas and procs have to be called later.
So a Ruby block is like a iffy?
Kind of.
Whoa, that kind of blew my mind a little bit. Huh. Okay.
I think. So yeah, like blocks are kind of anonymous functions, but blocks can also get passed in, passed around as like arguments and stuff. So it's weird. I don't know.
Okay.
It's just weird.
Fair enough.
I don't know how to think of that.
Yeah. Okay. So anonymous functions are cool because they don't load up your global namespace, but they have their own issues. They can be difficult to read in stack traces because they don't have a name, so it's probably going to give you that kind of garbled like function, some identifier thing.
And JavaScript error messages are so helpful already.
Yeah.
So.
Recursion without a function name requires the deprecated arguments.caller. So that, I think, goes back to what we were talking about with giving a function a name. It has a name, but it's scoped to that function and lower, but it's not scoped outside of the function. And names add meaning to a function. So if you name your function something, that in some ways defines what it is supposed to be.
This all seems like arguments for naming functions.
It is. Well, yeah, exactly. This is saying anonymous functions are great except these things.
Yeah.
So as it turns out, you can name your functions, your inline. So it uses inline functions first. So this is a callback. Saying once this is done and it waits a second, it's going to then execute this callback function. But they named it timeout handler, whereas in the previous example, it was without a name.
Right.
So you can name it. And likewise, with the ifs, which we talked about a minute ago, excuse me, you can name those too. And by naming them, you get all the benefits. It wraps the scope. It executes immediately. It's named.
Apparently, naming it iffy was like a thing there people did for a while, but he was like, "Don't do that," or "You don't need to do that."
Yeah, I saw that. It didn't seem to make a whole lot of sense to me to call it iffy because you lose that kind of semantic meaning of what that chunk of code is supposed to
What's that function trying to do?
Yeah, exactly.
Yeah.
So yeah, name your ifs, solves all the problems. And then blocks of scopes. JavaScript does not support block scoping.
Boo.
Boo. But remember that items in orange aren't true and are probably false.
Yay!
Yay!
JavaScript sort of supports block scoping.
Yes, with the with, which every time I see with mentioned in these books, it says don't look at this because with is bad.
Yeah.
It said also that in a try-catch, that the catch strangely has scope.
Yeah, I didn't pay attention to that because I'm not worried about error handling yet and stuff like that. So
yeah, exactly. It said that it does have scope, but that your linters will probably complain about it if you try to do something with that.
Yeah, I'm not worried about my linters, but I get your point.
Yeah.
Yay, constants.
Constants. Yes. So you'll see here that constant is block scoped. So you've got this block here, right? This if block.
Yeah.
And you have this constant keyword. It creates a constant. B, you set it to C. down here, you try to then set it to, or sorry, you set it to 3. Down here, you try to set it to 4, and it says, sorry, this is a constant. So what are you talking about?
Yeah, it throws an error saying like, hey, quit trying to change your constants, jerk.
Exactly, exactly.
Which is what your language should do. It should say, hey, stop trying to change your constants, jerk. Or, hey, you defined that constant three files ago and then included it. Stop
Yeah.
it. I had that happen to me. Like, stop trying to define constants that are already included in this file. Just because it's a good name doesn't mean you get to use it again.
Right, right. And then outside of this block, you can actually you can't even reference it. You get a reference error if you try to.
Yeah. It's
reference
like B. What's B?
Yeah, exactly. Scope's like, I don't know what this thing is.
Yeah, stop it.
And then there is block scoping with let.
Yay, let. Let's awesome too.
Yep, it's awesomeness. So we've got our explicit block we've set up here. We actually just said, I like curly braces a whole bunch.
That's what a block should look like. It should be a set of curly braces.
Yeah, I like curly braces. Let's make a block.
Yeah, and let is what we put inside of our pipes in Ruby.
Yeah, there you go.
Yeah. That is exactly what a block should look like.
And this actually goes back to Clojure that I'm learning, because pretty much you don't, I mean, let allows you to make variables in Clojure, but otherwise it's like, just stay away from variables, let's stick to functions. So the fact that let is used kind of reminds me of that there as well.
Let is a perfect solution for a problem this language has.
Yes, exactly. So it's creating a scoped variable inside this block, and it's scoped to that block.
Yeah, and then it goes away when the block hits.
Yes, exactly.
Yeah, no, this is what blocks should do. Blocks should have variables that are defined for the purposes of that block, and then when the block goes away, the variable goes away.
Yep.
That makes sense.
And you can use them as an iterator in the loop.
Yes, so you can.
Instead of using var here, which is then that I is scoped to that entire script.
Yeah, and it leaks outside.
Yep. And then if you use let instead, then it says, oh, that's scoped to this for block.
Yep.
And it stays inside and doesn't leak.
And so you actually get real iterators in JavaScript with let.
Mm-hmm. Exactly. And that's all I got.
That's awesome.
Sweet. So that was chapters 1 through 3. There was a lot of information in there, but I thought the book explained it really well.
Yeah.
And I understand scoping in JavaScript, well, period, I guess, because I didn't understand it after last week, and after reading those chapters, I do understand it.
Right.
So, yeah, I'm happy with those chapters.
And then next time we have let's see, hoisting.
Ooh, hoisting.
And scope closures.
Ooh, yeah, I want to talk about that.
And then we may touch on the appendices if whoever is making the slides wants to do them. But we got to find somebody to make slides.
Yeah, where are all the other people here to make slides?
I don't know. We'll have to shame some people into making slides. Then they have to show up too.
Yeah.
We're officially putting out the call. If you made it to the end of this episode, your job is to come into the You Don't Know JS channel on the Code Newbie Slack and volunteer to make the slides, because that means you got to the end of this first.
That's right.
Yeah.
Because whoever does get to the end of it first will reach out to us.
That's right. So, and if they don't, then by the end of the week, I'm sure I'll end up having to do it again. I need to redeem myself after my slide embarrassment fiasco last week.
What? There was no embarrassment.
Yeah, my slides were bad last week.
Oh, your slides were fine. You just had an issue with the background, and no one really even notices the background.
Yeah.
I had good luck. I used the Google, what I did this week, it was just the Google Slides, and I used one of their templates, and it was sweet, so.
Yeah,
Try
I'm
the
gonna do
Google
that.
Slides.
Yeah, that will be my action next time as well.
Sweet.
So, all right, man. I think we did it. So, how are you feeling about like the amount of content that we're taking on each time?
I
Like
think
this
it's
seems like pretty much the right amount, right?
Yeah, I would agree. I would say that this was a good amount. It was enough that it was, a good chunk for a week, but it wasn't so much that I couldn't sit down and do it in a few hours to
Right.
make the slides and then present it in an hour. So
Yeah.
yeah.
Yeah. Like one chapter, these books would be too little, but like a
Mhm.
whole book would be too much. After like the one we did tonight, the whole book would have been too much.
Yeah, I agree.
So yeah, cool. All right, man. Well, I vote we call it a night.
Sounds good. Thanks for joining in and reading the books. Thanks for suggesting the books. I think that it was an excellent suggestion.
Well, hopefully it keeps going well.
Yeah, and hopefully other folks show their support of that excellent suggestion and join in reading the books and making
Yeah, I
slides.
agree. And it's not too late. And then hop in on the books because, like, the nice thing is we're going by like stopping points. Like you're going to get the concepts if you watch the videos and then pick up where we are. So
Yeah,
hop in.
totally.
Cool. All right, man. We'll see you next week.
All right, sounds good. Have